In the previous videos, we focused on understanding the ERP from condition A. Now, what if we would like to compare the ERPs from two conditions? There are many different ways to do this, and we'll discuss one approach here. In this approach, our first step is to choose a statistic. A statistic measures some attribute of the difference between the two ERPs. There are many different choices we could make here, some of which are informative and some of which may not be informative. Let's start by choosing as our statistic the maximum absolute value of the difference in ERPs across time. Let's compute this statistic in MATLAB. To do so, we'll start by defining a new variable, ERP from condition A. To do so, we'll take the mean of the EEG data from condition A across trials. Let's also define the ERP from condition B. And again, we'll take the mean, of this case, the EEG data from condition B across trials. Then, let's compute the difference in the ERPs. We'll define a new variable, ERP, and I'll call it D for difference. To compute the difference, we'll simply take ERPA and subtract ERPB. We're now ready to compute our statistic. Let's define a variable stat, and we'll set it equal to the maximum absolute value of this difference. If we execute this command, we see we get a value of stat is equal to 0.2884. In isolation, this numerical value of the statistic is not very useful. Perhaps this value of the statistic is consistent with noisy scalp EEG that lacks an evoked response. Or maybe this value of the statistic is large and unexpected to occur unless the ERPs in the two conditions are different. To make this proposed statistic useful, we need to make stat, this variable we've defined, interpretable. Let's attempt to do so here, again using our bootstrapping approach.